Hello, dear students. In this practical, we'll talk about the non-destructive testing methods. There are three very commonly used non-destructive testing techniques, which are like say dye penetrant test, magnetic particle test, and ultrasonic test. So initially, we'll start with the dye penetrant test and its principle. Okay, so here what we do, the dye penetrant test is basically used for the identification or presence of the surface defects. Okay, so subsurface defects certainly cannot be identified by this dye penetrant test method, or the defects which are extremely fine, where the penetrant is not able to penetrate the defects, those also are found to be difficult to be detected by the dye penetrant test. Okay, so in this test, what we do, whatever the surface of the object or the weld joint or any casting which is to be checked for the presence of surface discontinuities, there the dye penetrant test method is used. In this one, what we do, we use basically three different types of the liquids. The one is a cleaner. Cleaner is applied on the surface of the object to be tested, so that all the impurities, oil, dirt, etc., if they are present, they can be removed, so that the surface is very clean and can be now exposed to the thin liquid of the low viscosity having the suitable dye, so that it can penetrate into the defect. Okay, so the defect can be of the different types. It may be in form of like the open holes or fine pores present at the surface, or the fine cracks, maybe say in the weld joint or in the heat affected zone, or it may be in form of hot cracks in casting, or like say the different types of the defects in the mechanically deformed components, or those which are manufactured by rolling or forging. So those defects which are extremely fine, they are found to be difficult to be detected using this method, but still we can see the fairly large size defects or fairly fine size defects also using the dye penetrant test. So after cleaning the surface, we apply the paint. So like say the suitable dye in the thin liquid of the low viscosity is applied. It is, you can say, the sprayed over the surface to be detected, so that the thin liquid can penetrate into the fine discontinuities and the defects which are present at the surface. And for this capillary action by which the liquid will be getting into those defects, some time is allowed. So after that, all this dye is penetrated into the defects and discontinuities, and after some time we clean the surface out. So after this removal of the dye, we apply the developer. So developer will be again spread over the surface, and so the developer basically sucks the dye. This is one approach. Wherever the dye which has penetrated into the defects and discontinuities, there will see the change in color of the developer. This is one of the approach. In other approach, the dye is cleaned, and then when the developer is applied, it gives the different kind of the shine or change of color. So there are different ways by which the presence of the defect in the surface can be identified. So if you see, there can be different types of the surface discontinuities. Here we can see a lot of open holes in the weld joint, at the open hole present in the weld bead. That's what we can see very easily using the naked eye. So there is no need of any NDT. So the defects which are really fine may be present along the toe of the weld or the weld center line, which may not be very clearly visible by the naked eye, but when we see it, when we perform the DPT, those are very clearly visible and can be seen. This is what also is visible. You can see that the crack is running all along the weld center line. It is typically indicative of the solidification cracking. Likewise, a lot of limited penetration or limited joining, you can say, at the toe of the weld, and these are highlighted after the dye penetrant test. So now we'll be performing these steps of cleaning, application of the dye, and then application of the developer. These steps will be performed systematically one by one to demonstrate how this test is performed in order to detect the presence of the surface discontinuities. Okay. Basically, this is about the first step where the cleaner is applied on the surface so that the surface is cleaned for the presence of the impurities in form of oil or grease or dust. These are removed. Once these are removed, then our these surface discontinuities will be exposed and they will be ready to suck in the dye which will be sprayed now. So the application of the dye is the second step. So now you can see the dye is being applied over the surface which is to be detected. You know that now some time is allowed so that the dye is sucked into these defects and discontinuities present at the surface by capillary action, and we allow some time for this process. Okay, so this is very important. If we do it, if we remove the dye very quickly, then the liquid may not be able to penetrate, and it is important for the penetration of the liquid having the dye is that it is thin, so that because of the low viscosity it will be able to penetrate the fine discontinuities or the cracks which are there at the surface. So some dwelling time is given after the application of the dye so that it gets sucked into by the capillary action into these defects and discontinuities present at the surface. So now we'll clean the dye which was applied, and the dye is wiped out from the surface over which it was applied, and this can be done with the help of a cleaner followed by the cloth. We can do this kind of cleaning using the cloth also. Now we will be applying the developer. So application of the developer will be sucking in the all dye or the thin liquid which has seeped into the fine surface defects and discontinuities. This is application of the developer. So here you can see that there is a dye we can see all along the weld center line, while other regions where there is no defect we can see just the white zone without any dye, while at the center the red colored the line indicates the presence of the surface defect in form of crack. Likewise, we can see some of the discontinuities here and there, but one big center line crack can be identified using this the dyed line running along the weld center line. So this is how we can identify the presence of the surface defects. So now we will talk about the magnetic particle test, and in short form it is termed as MPT. This test is mainly used for checking the near surface and subsurface discontinuities. Also, the surface discontinuities which are extremely fine can also be detected using the magnetic particle test, and discontinuities present the fine surface and near surface discontinuities present in the magnetic materials can be detected using this method. So in this one, the component to be tested is magnetized using electromagnetic approach. We can use the permanent magnets also, but more conveniently the electromagnetic method is used to magnetize the component to be tested. And whenever the component is magnetized using the electrical energy, the electromagnetic field is generated all around the zone wherever it is magnetized. But whenever it is done, let's say the magnetization is done using the this kind of yoke where it will be applied over the surface of the component to be tested. So obviously there will be the region which will be magnetized. Okay, so the line which is getting magnetized with the supply of the current. Okay, so in this line or the zone which is getting magnetized, if there are discontinuities, then there will be leakage of the magnetic flux. So wherever there is a leakage of the magnetic flux, that is exploited in this method. What we do, so after magnetizing the component through the supply of the current, the component has been magnetized, and once it is magnetized, we will be sprinkling the powder. Magnetic powder is sprinkled over the magnetized zone. So if there is any defect which is present, the magnetic powder particles will be getting collected, piled up in that area wherever the defects are present. Okay, so the piling up pattern will indicate the size of the defect, length of the defect, or if the defect is subsurface or surface. For example, if there are fine pores present in the subsurface zone, then there will be very hazy segregation, and if very clear fine crack is present, then the powder particles will be segregated along a particular line. Okay, so the way by which the sprinkled magnetic powder particle is getting segregated in the magnetized area, that will indicate the kind of the defect which is present at the surface. Now, in order to cover the entire zone, because right now what we are seeing, this is the zone which is getting magnetized. So in order to scan the entire area, we can keep on changing the position of the magnetic of this yoke, so that all the area is scanned one by one. So say in typical weld joints, we may be interested in transverse direction and longitudinal direction, that is the welding direction. So we can check once like this. So all the discontinuities present perpendicular to this parallel to the weld line, they will be easily detected, and when we set the yoke along the weld line, it will be checking the discontinuities present perpendicular to the weld line. So transverse discontinuities are detected this way, and the longitudinal discontinuities are detected when the yoke is placed perpendicular to that of the weld line. Okay, so I mean to say, if the surface which is being checked is not a weld joint, then we have to magnetize the workpiece to be checked using this kind of the device at large number of orientations, locations, so that the entire surface area can be detected. So in that way, this is little slow, but it helps us to detect the presence of extremely fine surface defects which in general are not detected in the dye penetrant test method, or the defects which are present in the subsurface zone. Those can be easily detected using the magnetic particle test method. So now we'll be showing the demonstration how this kind of the test is performed. So now you can see the yoke has been placed perpendicular to the weld line. So whenever the switch is kept on, there will be flow of current, and that will help to magnetize. So you can see that how it is being magnetized. Okay. So when it is magnetized, at that time we can sprinkle up. So this is how the powder, magnetic powder, is being sprinkled over the surface to be tested. And now, yeah, you can see it is magnetized. So the powder has got segregated at a particular location. Yeah, you can see wherever it is segregated, that is indicating the presence of defect. Okay, so here we can see the powder particle segregation along these lines, indicating the presence of fine cracks perpendicular to the weld bead. Okay, so now we can keep on changing the orientation to see that if the weld defects are present at other locations or not. Okay. So in this case, whatever we see, that wherever there are discontinuities, there our powder particles have got segregated. So that is indicating the orientation, location, and the size of the discontinuities which are present. So here we can see this is the small disc having the defect in the subsurface zone or surface zone, which is extremely thin and not visible by the naked eye. So but that can be easily detected using the magnetic particle test method. Here this will be magnetized, and the powder particles will be sprinkled, and then when it is magnetized, those will be getting segregated suitably, and that will indicate the pattern, size, location where these defects are present or the cracks are present in this typical sample, small size sample. So you can see here, now we are putting in the magnetic powder particle in the sample which is to be tested, and now it will be magnetized. So here you can see what we have done. We have spread the powder particle. After that it was magnetized, and that has led to the segregation of the powder particle here. So the location where powder particle have segregated, that is indicating the size and the type of defect. Since it is very linear, so suggesting the crack, and since it is very clear piling up of the powder particles, so it is the fine surface crack which is present in this object. So even fine objects can also be tested using the magnetic particle tests for the presence of the surface defects. So now we will talk about the ultrasonic test. Now ultrasonic testing is used for the multiple purposes. It uses the ultrasonic vibrations or sound waves which are allowed to pass through the object to be tested, and when these waves strike the particular interface like air to metal or metal to air or metal to some kind of the discontinuity, then these waves are reflected back, and this is the simple principle which is used in different ways for the testing using the ultrasonic approach. So ultrasonic approach, one of the simplest thing of using ultrasonic testing is to check the thickness of the object. So this can be used to check the thickness of the sheet or thickness of the films or thickness of the of those steel sheets or objects which are accessible just from one side. Like if there is a huge steel wall, then its thickness we can simply check by having the access of the wall from one side. We don't need the access from both the sides. So this is one simple kind of the device which we can say ultrasonic thickness tester. So in this case what we do, there is a probe which will be sending the ultrasonic vibrations as well as receiving also. So when this probe is placed over the object, it will be giving us directly the thickness of the sample. Say thickness of this sample is 27.2. So likewise we can put, so this is what you can say, 27.2, and here likewise we can place it over the any metallic sheet or any object. Okay, say for this case, this thickness is 6 mm. So I mean to say, wherever there is the access from one side, the thickness of the objects can be easily checked. So the coatings, films, sheet metal, or the pipe thicknesses which are accessible just from one side, those kind of things can be easily tested using the ultrasonic thickness tester. And the similar principle is used for checking the discontinuities in the metallic objects. So what we do in that case, the probe is of the similar kind. So when there is a no defect, say in this case, so what happens, like the probe is applied on the surface. So the one interface is of the probe and the metal. So that's the air to metal is one interface. So we will be getting one peak in the beginning. This is the first peak, and if there is no discontinuity, then the second peak will be getting from the other interface, which is on the bottom side of the metal, and then air. So the another peak of the reflection, so the one is the entry peak and another is a reflected peak. So the reflected peak will be visible at some distance. That will depend upon the distance which is traveled by these vibrations or the ultrasonic waves. So thicker the plate, greater will be the distance. Greater is the distance of the discontinuity from the surface, greater will be the distance of the intermediate peak from the main entry peak or the surface peak. Okay. So we are not able to demonstrate the ultrasonic testing approach for the defects, but the principle is of the similar kind. Here what we have demonstrated or what we'll be demonstrating is the thickness testing. Okay. So initially we will be using the coupler, and coupler helps in better connectivity of the probe with the object. So first of all we try to calibrate the things so that it is corresponding to a particular standard. Here calibration block is of the 5 mm. So when it is calibrated, once the things are calibrated, our probe is ready for the thickness testing. So now this probe, which is having a little bit coupler also at its surface, is applied over the surface of the object whose thickness is to be checked. So it will directly give the thickness testing, ultrasonic thickness testing will directly give the value of the sheet which is being tested. Okay. So here in this case, say it is how much it is? 27.2 mm thickness. So that's how thin films or thick films or thick plates, anything we can check using the ultrasonic thickness tester.